Hey everyone. Hope everyone's having an awesome week so far. Um, this video is to show you how to transform a graph. Um, just given a random graph, as you can see with this really random thing. Um, so this graph is called f of x, as you notice here. So y equals f of x. And the directions are, given the graph of f of x, sketch a graph of g of x, given the rules below. So what we're going to have to do is see how these different transformations, which they're calling g of x, because we can't call it f of x since that's already being taken for the original one. So with these types of problems, they give you a graph. They'll give you a graph. In this case, it's this random thing of segments added, combined together, and we're going to have to apply these transformations. Okay, and what I did over here on the right was there's another one. We will get to that one last. So what I did over here on this table right here is what I made. I copied these points over onto this table. And if you notice, I went in order. I started with the leftmost point, and then I went left to right. So I did this point, then that one, then that one, then that one, then that one, and then that one. Okay? And that's the order that I got on this table. And this order is going to matter just because when you're graphing the actual transformation, which we will do at the bottom, when you're graphing these transformations, and you write these points in order from left to right, you'll be able to know like what connects to what. If you just kind of randomly write the points and you graph the transformations, it's kind of difficult to know which point connects to which point. Okay, so here's the general rule. Okay, now this is it's a lot of information here. Okay, so you're either going to have something in the parentheses or a transformation outside the parentheses. Any transformation that's outside the parentheses is going to affect the original y coordinate and only the y coordinate. And to find the new y coordinate, you're going to follow order of operations. And when we do an example, it'll make more sense as to what this means. And so you might either have something outside the parentheses or something inside the parentheses. And anything that's inside the parentheses is only going to affect the x coordinate. And what you do is you set each part equal to the original x coordinate and then solve for each x. So, for example, this is what's in parentheses, right? So when we get to this one, I'm going to set every original x value over here equal to this over here. And then when I solve, those will be my x values. Anything outside, so in this case I have a -2 right in front of f and then a -1 at the end. These in blue are only going to affect the y. Okay, and then for those you're not solving, you're not setting up an equation, you're just kind of going, you're following order of operations. Okay, and let's just highlight over here. So in orange, in the parentheses, I have nothing. In these parentheses, this is a hint that the original x values are not going to change with these transformations. And then we have times -3/2 in the front. And then for this one, the only thing I have outside the parentheses is this 2. And the only set of things I have inside of parentheses is this x plus 2 part. Okay? So I have the original tables for each. I have the original table of my, I guess we can call this the OG one. of my original f of x. This is the original table, and then we're going to see what happens with this new one. And I'm going to color code this because over here at the bottom, these are color coded so you can see. I'm going to put them all on one graph. Okay, so let's just focus on the x's for now. So what I meant for setting an equation up for all the x's is I'm going to take this part in parentheses and I'm going to write that over here. So for each x value, and again, these only affect the x value. So it's kind of like you're making, in this case, you're making 6 different equations. X plus 2 equals negative 4. X plus 2 equals negative 3. X plus 2 equals negative 1. X plus 2 equals 0. X plus 2 equals 2. X plus 2 equals 5. And these are the ones where you have to solve, meaning you're going backwards. So you're trying to figure out what x is equal to for all of these, and then that will give you your new x coordinates in the new table. So, which in this case is, we're calling the new y is g of x. All for x, I'm going to subtract 2 from both sides, and we get x is equal to negative 6. Okay, so that's, I'm not sure why they changed colors on me. So this first point is negative 6. Solving for x for this one, we get x is equal to negative 5. The next one's going to be negative 3, and then negative 2, and then 0, and then 3. Okay? So now this kind of transformation, I'm sure some of you were like, well, this is saying x plus 2, so don't we know that it moves 2 to the left? And wouldn't it be easy to just subtract 2 from both sides? Yes, absolutely. But I want you guys getting in the habit of that, because if you see something like this, it's not as clear what's happening. And this also explains, by the way, why whenever something is in the parentheses and grouped with x, we end up doing the opposite. So this is why x plus 2 really means we move to the left 2, is because we're solving. Okay, so anyway, I'm not doing the work for the remainder. I hope you get it over here. So all of these new x coordinates are the way they are because of what was in the parentheses. So this part, this x plus 2, only affected the x values. We don't have to worry about that, this 2 out in front over here that's in blue, because that's going to affect the y. Now for the y, you don't have to set each of these numbers in blue equal to the original y's. You follow order of operations. You're not solving for them because they're not inputs. So what we're doing to all of these y values is we're just going to double them. That's technically multiplication. So I'm going to take all these y values and just double them. Zero times 2 is 0. That's negative 4. That one's also negative 4. And then that's going to be 0. And that's going to be 6. And that's going to be 0. Okay? So all of these new y coordinates are the way they are because of that blue 2 that's out in front. Okay? So this is my table for this new graph. All right? So now when I'm graphing this, I'm going to keep this, make sure I'm in red. So negative 6 comma 0. And because I wrote these in order, as I was saying earlier in the video, I can connect them left to right, and you get that. So this is the same as the original image, But because there's a 2 out in front, it's now twice as tall, and it is shifted 2 to the left. Let's try this with the middle one. Now, there's nothing in the orange part, nothing in the parentheses, so you know that in this new one, the x values are not going to change at all. And this was green. So let's make a table for this. X, g of x. So because there's nothing to do in the parentheses, I'm just going to copy them all down. They're the same as the originals. All right. And then for the y value, what's going to happen to each one is you're going to multiply each one by -3/2. Okay. So a quick way to do this with a calculator is just put -3 divided by 2, and then times whatever the y values were. -3/2 times, what was the second one? -2. Okay. And then just do that for all of them. And then 3, and then 3. So again, with these, I'm only multiplying the y values. All right, so I have the table for this, and I think you guys can figure out the graphing part, so I'm just going to go ahead and jump right into doing this last problem. Okay, so this is where you start seeing why this information is so important. With all these different types of transformations inside and outside the parentheses, it can be a little crazy. So if you follow these steps, it won't be so crazy. Let's go ahead and we can do the y part first for this one. So notice we have a -2 and a -2 in front, and we have a -1 at the end. So it's like, okay, do we subtract first or do we multiply first? And again, remember, this means multiplication. So with the y's, you follow order of operations, as noted by the last asterisk in blue. So I'm going to take all the original y values. So we have to follow order of operations. I'm going to multiply by -2 first, and then subtract 1. So basically for all of these, it's going to kind of be like this. Okay, so here's really what's happening with all the y values. Okay, so now all these numbers in parentheses over here in black are the original y values of the graph. Okay, and with each one, following order of operations, multiplying by -2 and then subtracting 1. Okay, so that's what this part over here means, this last asterisk in blue. All right, so I'm multiplying the 0 by -2, subtract 1. That gives us -1. This would be +4 minus 3. +4 minus 1, which is 3. This would be +4 minus 1, which is also 3. This will be -1. This is going to be -7, and this one will be -1. Okay? So these are all my new y coordinates over here in green. Now to find the new x's, remember, you're not following order of operations. I'm going to take that 4x plus 1. So I'm just taking the part in the parentheses, and I'm going to set it equal to each original x value. Okay, so I'm setting them equal to all of these. I'm going to do for each one to find my new my x coordinates. So, and some of these are going to be kind of funky numbers. So for this one, to get x by itself, I subtract 1 from both sides. This gives me -5, and I have 4x. Last step is to divide both sides by 4. By 4, x is equal to -1.25. Solving this one, subtract 1, subtract 1. Is going to look like this. I'm just going to make sure I follow these in order. -1.25, -1, -0.5, -0.25, +0.25, and 1. And then let's copy these y values from here. And this is my new table for this for the green transformation. Why is that green? That should be blue. Oops. Okay, now it's blue. All right, so here are my graphs, or here are my tables. So for this one, for the blue one, -1.25, we're going to have to really just guesstimate over here. And then let's go ahead and plot the green part. -4, comma 0.
-3, comma 3. -1, comma 3. 0, 0. 2, -4.5. And 5, comma 0. So,
in comparison to the original one, the one in green has this original one flipped over the x-axis because there's a negative right in front, and it's 1.5 times as tall. The main thing to get out of this is if you have a transformation, if you're transforming a graph and they give you a function, a random function like this, then to apply its transformations, you just got to really worry about the numbers that are inside the parentheses, which only affect the x, and the numbers outside the parentheses, which only affect the y. Anything affecting the y, in which I highlighted blue, is going to affect the y once you follow order of operations. But for the ones in orange, you set each original x coordinate equal to this part in orange, and you solve each to find out your new x coordinates. Okay? And that is that. If you have any questions, please feel free to ask away. This will definitely help you on the homework. And the homework you don't have to grab if you're just making the new tables. All right? Hope this helps everyone. I apologize for a longer video, but I hope you guys all get something out of it. All right? Have a great one, everyone.